So hi everyone, my name is David, and thanks for coming to my talk. First of all, I would like to apologize for my voice. I somehow lost it yesterday, and believe me or not, I mean, this has nothing to do with the party of yesterday. So it's kind of annoying, but I will do my best. So I'm really pleased to be here today to talk to you about all the work we are doing in Apache Kafka to improve the scalability and the stability of consumer groups. So I guess if you are here, so that you are basically familiar with consumer group already, but we will do a quick recap anyway. So I will start with explaining what consumer groups are, just to make sure we are on the same page. And then we will look at all the new stuff we are implementing in Apache Kafka these days. So first we'll look at this new consumer rebalance protocol, which is basically like the core change that we are doing to improve consumer group. Then I will discuss a bit like the new group coordinator, which is basically the service running on the server side, managing the group state and everything. Then we'll discuss the new consumer that we are building, and then I will finish with a few takeaways. So consumer groups. So I guess that you are all familiar with that already, but like in Kafka, if you have a topic, a topic is divided up into partitions, and partition is basically the level of parallelism that you can have, right? So if you have two brokers, like we have here, with a topic called bar, with 4 partitions, and then on the other side, you have a consumer group with three consumers. Basically, what you want is to basically assign those partitions to those consumers so they can basically fetch from them, right? And this is basically where the consumer group protocol kicks in, right? It's basically there to allow those consumers to synchronize themselves and agree on an assignment, right? So in this case, A will consume from 0 and 1, from 0, sorry, B from 1, and C from 2 and 3, right? And whenever you have a change in the topology, so for instance, say that C dies for whatever reasons, the protocol is also responsible to recover and to reassign those partitions. So in this case, 2 and 3 will be reassigned to A and B, right, to continue the processing, right? So this is basically what consumer groups are. So it's a pretty simple concept, but which is extremely important in Apache Kafka, right? Because all the consumers basically rely on it. So now let's dive into the interesting stuff. So first, I would like to explain the new consumer rebalance protocol that we are building. But let's start by discussing why we need it. And there are actually 2 reasons for that. So the first one is the current one that we have has actually a fundamental flaw in its design, right? It basically relies on what we call a group-wide synchronization barrier, which basically means that whenever you have a rebalance, like we had in the example, all the members has to basically rejoin the group and synchronize themselves together, right? Which basically means that if we have a slow member, for instance, in the group, all the members will have to wait on him to complete the rebalance event. So this is not so nice. And the second thing is in the current architecture, the consumer is quite powerful, right? So we do the assignment on the consumer side. The consumer is also responsible to track metadata, to trigger a rebalance when partition is created, for instance. Is it also responsible to resolve regular expression, and so on and so forth, right? And this is quite annoying because if you have when you have that amount of code and logic on the client side, first you cannot share it for other implementation of the client, right? So you have to implement the same thing over and over and again, and that's pretty complicated, right? And the second thing is whenever you have bugs there in a code which is pretty complicated, then you have to wait on really cycles to basically do fixes, right? So what we want here is to basically simplify the consumer to really move the logic as much as possible to the server side. So I've been explaining this protocol quite a lot in the past few months, and I think the best way to look at it is to basically look at an example. So what I want to do is start with a basic case where we have 2 consumers, then we will add another one, and then one will fail. So pretty standard life cycle. So in this slide, on the right-hand side, you have the group coordinator. And there, we basically have 2 important concepts. So first, we have what we call the target assignment, which is basically a declarative assignment for the group. This is basically what we want to have, right? So in this case, the target assignment is at an epoch 5, which is a number we have here, and basically stipulates that A should have like P1, P2, and P3, and B should have like P4, P5, and P6, right? Then the second thing we have is like the current assignment, which is basically what the consumers should have at the moment. So at the moment, it has, in this case, exactly what it's supposed to be, right? And all this state is basically stored like durably in a log, right? On the other side, we have like the two consumers, A and B, and they also have what they're supposed to, right? So A has like P1, P2, and P3, B, P4, P5, P6, right? So the group is stable, everything is assigned, easy. So the first thing here is like we are basically introducing like a new protocol between the client and the server, which is basically like a single new API, which is the consumer group Herbit API, which is like a multi-purpose RPC, which is used to do liveness, so to basically ensure that that the members or the consumers are alive, right? It's also used to propagate subscription of the consumers to the server, like the topics they are subscribed to, the regular expression they want to monitor. And then it's also used to propagate assignment from the group coordinator to the members. So in this case, A will send like an Herbit request, which basically contains like an ID, A, like an epoch, 5, and then the dash basically means that the assignment hasn't changed. On the server side, when we receive like such a request, first the server will basically check if the member exists and if the epoch basically matches what is expected. So in this case, we receive 5, we expect 5, it's all good. Then the second thing that the server will do is like it will check if the current assignment matches like the desired state, the target assignment. In this case, they are, so there are nothing to do, so the server just reply to A, right? In the case of B, it's exactly the same. Now, let's imagine that C joined the group. So when a new member joined the group, it starts with like an epoch 0, is what we have here. It will send a request without a member ID. And then on the server side, the first thing that the server will do is like generate like a new target assignment, because like we have to generate like a new desired state for the group whenever we have a change in the topology. How does it work? It basically will rely on like the server-side assigner and provide it like two things. The first thing is like the current target assignment at generation 5 here for A and B, right? And then it provided like the subscription. In this case, they are all subscribed to this topic called P. And then like the server-side assigner will generate like a new target assignment at generation 6, right? So in this case, we see that P3 was moved away from A and assigned to C, and P6 is basically moved away from B to C as well, right? Then this is basically installed and stored like durably in the log. When this is done, like the server side will basically compare like the current assignment with the target assignment. And in this case, it don't match. So it will basically start like what we call like a reconciliation process. So it will basically take like all the steps required to basically convert that member to what we want him to have, right? How does it work? It's like a 3-step process. So the first thing we have to do is like revoke like all the partitions. And it's important to start by doing that because we want to basically commit offsets and everything with like the current epoch of the member to basically ensure like a clean handoff between like the old and the new member who will get the partition. When this is done, the member can transition to the new epoch, which is like the epoch of the target assignment, and then we will start to assign new partitions as they get freed up by other members in the group, right? So in this case, the only thing we can do is like use like the epoch 6. So there are no partitions to revoke, so we can go to this step directly. But as you can see, like P3 and P6, they are still assigned to A and B, right? So we cannot use them yet. So in this case, we just reply, okay, you've got like the member ID C, you should have epoch 6, and your assignment is basically like an empty array, right? You have nothing to do so far. Then when A heartbeats next, right, it's still saying like A and 5, and the server will basically realize, okay, now like the current assignment doesn't match the target, right? So I have to reconcile this member as well. So as I said before, we start by revoking partition first. So there it will basically realize that P3 has to be revoked, right? So in the response, it will basically say, hey, you should have P1 and P2 now, right? So please like revoke P3. So A, when it gets a response, it will compare the assignment it should have with what it has locally and realize that P3 should we revoke? So it will basically start like the revocation process, right? So it will fire all the callbacks we have on the consumer, commit offsets, and do all this stuff. The same goes for B, right? P6 should not be there. We send like this assignment to B. B realizes it just has to revoke the partition, so it starts the process as well, right? In the meantime, C keeps her beating, right? But there are no changes, so we cannot move and assign partition to this member yet, right? And as long as members are her beating and not like acknowledging that the partition can revoke, we are basically remaining in this state, right? So let's say at some point, B is done with a revocation, right? So in one of the following heartbeat, you will say, hey, now I own like P4 and P5, right? So the coordinator will basically use that and say, okay, now it basically owns what it's supposed to have. So basically P6 is gone. So I can transition to the epoch 6 and complete the reconciliation, right? So it provides like in the response like epoch 6, and B is like fully reconciled, right? Now when C heartbeat next, the process to reconcile him can basically continue. So this time like P6 is like free, right? So we can assign it to this member. So we basically provide it in the next heartbeat response, right? So basically C can now start to assign like the partition, fetch the offset synchronously and start the processing. In the meantime, let's assume that A fails, right? So if it doesn't heartbeat, within the session timeout, the group coordinator will basically realize that and remove it to the group. So what happened in this case? Well, we have to generate like a new target assignment. So it will basically generate like the generation set of this target assignment and assign like the partitions that were assigned to A to now B and C, right? Those P1 and P2 partitions we have here. So when B heartbeats next, we will reconcile like the current assignment with the target assignment and realize that, okay, we can bump to the next epoch, 7, and start the assignment of P1. We reply to B, B start the assignment, and move on. Then let's imagine that C is done like with like the insertion of a partition. When it heartbeat next, it basically acknowledges that. So the reconciliation can basically continue. And in this case, the group coordinator basically realized that the member can move to 7, and then that P3 and P2 are actually available, right? And that can be assigned to the member. So we provide them in the response. The member can assign them. And then we keep going, right? So B is now done with assignment, acknowledge that to the server. So like B is like fully reconciled. C will do the same, is fully reconciled, and then the group is stable, right? So when you reach this state, like member just like keep heartbeating as long as like there are no like triggers to compute like a new target assignment. So what we have seen in this example is like we don't have like any like global barrier anymore, right? Like the member is basically synchronized like by the group coordinator based on the availability of the partitions, right? Which is like pretty nice. And the second thing is like all the logic is actually like driven by the group coordinator, and the state machine on the client is like really simple. So now let's look at the group coordinator. So what we realized pretty early in this project is like when we designed like the new protocol was that there is a need for a new coordinator, because like the one we have in Apache Kafka now was basically written like 8 years ago, and it was really tailored to like the protocol we have, right? And we realized pretty quickly that implementing the new protocol in there was nearly impossible, and for a few reasons. The first one is like the state management is completely different. Like in the current protocol, we write to the log like once per rebalance, whereas in the new one, we basically have to constantly update the state, like the target state, the current state of the members, and everything, right? So the state management is completely different. The second thing is like the concurrency and the trading model in the current code is extremely complex. So we had like so many issues, deadlocks, that we wanted to do something slightly better. And the third one, it was also like a nice excuse to move away from Scala to Java. We have this big initiative in Kafka to basically rewrite everything to Java nowadays. So we thought, okay, we can just do it here for this component as well. So how does it look like in this new architecture? So I will start from the right. So on the right, we have like this special topic called the consumer offset topic, which has like 4 partitions here. And this is basically where we store, all the metadata of the groups, right? In the new architecture, like all these partitions are basically mapped internally to what we call shards, right? Where basically every shard is responsible of running like a replicated state machine for all the metadata of the group like owned by this partition. Then in the middle, we have this queue and an event processor, right? So what is really new in this new model is like now like the consumer group coordinator has like a dedicated thread pool with like its own queue. So whenever we get like RPCs from clients, like they are basically put in the queue as events, right? And then they are picked up by the processor to be applied to the shards, right? And there is one important thing here is like a shard are basically non-thread safe component, right? So the event processor has to basically guarantee that like event, like for the same shard don't apply concurrently, right? They have to be serialized internally. If we zoom into a shard, there we basically have like 3 main components. So first, we basically have like some business logic, right? Because we need to process those requests and do something with them. Then we have like a replicated state machine, and we also have like a purgatory. So how does it work? So when a request comes in, like the business logic, might use like the state of the current group to take decision, right? So for instance, it will basically consult like the target assignment or like read the current assignment to the epoch of the member. And based on that, it basically generates 2 things. It generates like a set of records and also like a response. With the records, we basically, apply them to the state machine to basically update the state locally, and then we write them to the log, right? So in this case, we see that we have like 8 and 9 for the new records. And when this is done, we basically put the response into a purgatory to basically have it wait until like the new records are committed, right? So in this case, we add an entry and say, okay, this response can be released only when like offset 9 is committed, right? So later on, when new offsets are committed, so say for instance like 6 and 7, like the log layer notify like the shard component and say, okay, I've committed everything up to offset 7, so you can release those requests and send them back to the client, right? And we will keep doing that whenever stuff are committed. We also have got like a new set of new configuration. And here, the first one is extremely important, right? As I said, we now have like a thread pool for the group coordinator. So whenever you upgrade your Kafka cluster, when we release these features, you will have to, choose a number of threads wisely, right? So by default, it will be 1, which is probably not enough. The second one, which is like important, is like the group consumer assigner. So as I said earlier, like the assigner function is now run on the server side, right? So you have basically here you can basically configure the one you want to support for your consumer group. So by default, we will have like 2, uniform and range. And then we have like 2 other, 2 other like configuration settings. The first one is like the session timeout you want to use for your consumers, and then also like the heartbeat interval, which are basically respectively set to 45 seconds and 5 seconds. So server-side assigner, we will basically ship, with 2 by default. So there will be like the range assigner that we already use today, which basically like co-partitions partition. So if you subscribe to 2 topics, say blue and purple in this example, right, it will basically ensure that the partition with the same index are assigned to the same member. So in this case, 1 and 1 are assigned to A, 2 and 2 to A, and so on and so forth, right? So this guarantees that you can do joins between partitions with the same index, but basically it doesn't ensure that you have like the load which is like widely spread in your consumer group. Then we will support like the uniform assigner, which basically does the opposite. It doesn't really care about like co-partitioning at all, but basically will spread like the partitions as much as possible in the consumer group to basically have like a node which is like evenly distributed in the consumer group. And then you can basically write your own. So there will be like a pluggable interface, so you can implement your own logic and do whatever you want there. Okay, so as I said, we will have a completely new group coordinator. It's already in AK at the moment, but it's not enabled by default. What is important to know is like, we will make it the default at some point. We don't know yet. We don't know when yet. It's going to be next year, maybe in Apache Kafka Photo or something like this. So what is important to know is like, it's fully backward compatible. So from a feature perspective, it has no changes. But as I said, like the threading model is completely different. So you have to be wise and careful when you upgrade your cluster when we do that. Oh, sorry. So the next chapter is about like the new consumer. So why do we need a new one? So there, it's pretty simple. I don't know if you know this, but the threading model in the current Apache consumer in Java is a bit weird, right? So initially, it was designed to be entirely run on the application threads, right? So if you're familiar with it, you can basically call this poll method in the consumer, and this is basically where the magic happens, right? We will basically send requests, fetch records, provide them for processing and everything. But there is like a catch, right? In order to maintain the session with a group coordinator, we have like a thread running in the background to basically send a heartbeat at regular interval, right? And that one has been quite nasty in the past. So for two reasons. We had many concurrency issues there. So you might say, okay, we are capable engineers, so we should be able to do concurrency right. But apparently we cannot. So we always have like tricky bug there, which is really annoying. And the second thing is like, this one also uses like a network client internally. So we basically have like the application thread and the heartbeat thread like using the network client, and they compete with each other there. And we had like really nasty side effects due to that. So we said, okay, given that the heartbeat, is like supercharged with a new protocol, like this model doesn't work. So what we decided to do is to really embrace like an event loop-based kind of mechanism, like we have in the producer. So what we have in this picture is like we still have like the application threads, obviously, right? But then now we have like a background thread, which is basically responsible to run everything in the background. So whenever like the application threads like does something, we basically post like an event into a queue, and then we have a thread running in the background, updating the state of the consumer based on that, doing like network call and all the I/O in the background, right? So now we have like a clear separation of concerns. We also have got like a few new configuration on the consumer. So the first one, which is like the most important one, is like the group.protocol, which is basically used to stipulate which protocol you want to use. So we will support like generic, consumer, and auto. Generic means like the old protocol that we use today. So if you set it like this, you keep using the old one. If you set it to consumer, you will be using the new one. And we plan to have like an auto mode where like the consumer will be smart enough to use like the right one. And the second one, which is new, is this group local assigner configuration, which is basically there to let you select the assigner you want to use on the server side. So by default, it's set to null, which basically means that the server will basically choose one for you, but then you can specify like one if you need a specific one. There will be also like some API changes. There will be many, but the biggest one is around how we subscribe with regular expression. So I'm pretty sure you're familiar with that, but you have the subscribe method. We can provide like a regular expression in Java, and then the consumer use that to basically monitor the metadata and decide like the patch that need to be fetched based on this regular expression. So we have basically decided to move this functionality to the server side. So this is why we are deprecating like the one using like the Java pattern API and replacing it with like this new consumer subscribe with like this subscription pattern thing. And when you use this one, like the resolution is basically done on the server side, right? And this is pretty nice, right? But as you can imagine, if you have like 1,000 consumers, like all having like the same regular expression in the current model, they all have to like to do this resolution locally, right? Which basically mean like fetching like all the topics in the cluster to figure out which one they have to consume from. By putting it on the server side, assuming you have like only like a few regular expressions per group, we can basically do it once, basically for everyone, right? So it's way more efficient. Something which is really cool is like how we are going to handle the upgrade path, right? So because we have like an old protocol, we have a new protocol, and we have to upgrade it. And here we really plan to make it really easy for you guys by supporting like a live upgrade from the old to the new protocol. So let's go through like an example. If you have like 3 consumers like A, B, and C, for instance, like configured to use like the old protocol, right? say that you update the first one to use like the new protocol. So you set this group protocol to consumer, like the A will start to use like the new RPC to connect to the group connector. It will realize that, and then in the backend, we will basically immediately convert the group from the old model to the new one, which is based on the target assignment. And this is where the magic happened, in a sense that for the old protocol, we will basically like proxy everything into the new one automatically, right? So it's basically like fully backward compatible there. So you can basically upgrade like B and C, slowly by doing like just like a rolling upgrade. And at the end of the day, they will all use like the new protocol. And like the opposite process will work as well. So if you have like any issues, you can basically downgrade directly. So to conclude, I was here like a year ago to basically announce this KIP. Today we have merged like 120 pull requests, so it has been like a massive effort in the community. We probably have about like 10 community members working on this, not full time, but investing like a lot. The new group connector is like more or less fully implemented and merged into trunk, so we can already use it by setting like a specific configuration. Now we are working hard on like merging all the code for this new consumer trading model, refactoring, and also implementing the protocol on the client side. And our aim is to have like a review in one of the next release of Apache Kafka, maybe 2.7, but we have to see if we can catch it or not. If you want to know more about the protocol and what we do on the consumer side, I've linked here like 2 documents explaining like the design of both, right? And to conclude the talk, I would like to leave you with like a few takeaways, right? So what I've shown here is like we have basically like developed this new protocol, which is like truly incremental, right? With the aim to have like more stable and especially like more scalable consumer group, right? So here we really hope that we will be able to go into the thousands, right? Which is something which is not possible today with the current protocol. The second thing, which is really important, is like we will have like a consumer which is like way simpler, right? And this will allow to simplify the code in the Java client, but also to simplify the code in all the other clients we have out there, right? By reusing like a simple state machine and moving like all the core functionalities to the server side. And last and not least, we will support this online consumer group upgrade, which is really important, to migrate workload like seamlessly to this new protocol in the future. So that's all I have. Thank you guys.